All right, good afternoon, folks. Welcome back to another video on Intro to Algebra. This is Mike coming back at you. In the previous video, we talked about properties of real numbers. Associative, commutative, distributive, identity, and inverse properties. In this video, we're going to wrap up Chapter 1, and we're going to talk about simplifying algebraic expressions. But before we talk about simplifying algebraic expressions, let's talk about the things that make up these algebraic expressions and those building blocks, if you will, those pieces of algebraic expressions are called terms. So what is a term? A term is a number and or a variable. It could just be a number. It could just be a variable. Or we could have products or quotients of numbers and variables, or we could have variables or numbers raised to powers, or something like that. If your term contains a number, then the number in a term is called the numerical coefficient, or more commonly, you'll just hear it called the coefficient. So just a quick sample of what I'm saying here. In the term 5 times x squared, or x raised to the second power, 5 is the numerical coefficient, or just the coefficient. We don't really have any other name really for the rest of the term. We don't really have a name for the x raised to the second power piece of it. We really just say that it's x squared, or x raised to the second power. Now, a key piece in simplifying algebraic expressions has to do with combining like terms. So what are like terms? Two terms, or even more terms, are like terms if they contain the same variables and the same powers on each variable. You could have one variable, you could have two, or even more, and if the same variables have the same powers, then those terms are like terms. Key thing here, the coefficients, the numbers in front, do not have to be the same. But as long as the variables are the same and the powers on each of the variables are the same, then you have like terms, and those things can be combined. So a few samples here. We're just going to say whether each pair of terms are or are not like terms. So here, looking at the 3x squared and the 2x cubed. Okay, well, these each only have one variable in them. They each just have an x. That's good. Now we have to check the powers. Are the powers the same? Well, this one has an exponent of 2. This one has an exponent of 3. Powers are not the same. So these are not like terms. Again, not like terms because the powers are not the same. Next one, 10x cubed and t cubed. Are these like terms? Well, we see that the powers are the same, so that's good, but we don't have the same variable happening here. We have an x here and we have a t here. So since the variables are not the same, we cannot say that those are like terms. Okay, 5 times x times y squared and negative 2 times x times y squared. All right, this term contains an x and a y. This term contains an x and a y as well, so that's good. Now let's check to make sure the powers are the same. This has an exponent of 1 there. If we just see a variable and there's no power on it, secretly we have a power of 1. We just don't write that exponent of 1. And same here. We just had x, we just had x. So those things have the same power. And here we have a power of 2 on the y and a power of 2 on the y. So we have the same variables and we have the same powers on each of those variables. So yes, these are like terms, and these could be combined. And the last one, I'm going to let you try that one on your own. see if you can figure out as to whether or not those two terms are like terms. Okay, so now we get to the actual simplification process. What do we do when we, say, simplify an algebraic expression? An algebraic expression is simplified when the following three things have happened. One, all grouping symbols have been completely removed. Two, all like terms have been combined. And three, all operations have been performed where possible. So the three things. Grouping symbols are gone, like terms have been combined, all the operations have been performed where possible. And when we say all operations have been performed, we mean operations having been performed on those like terms. So we'll wrap up this video with some samples as to where we do some simplifying here. All right, so first one here, 3 times the quantity 2x minus 4. Starting off very basic here. I have some grouping symbols here, so these guys have to go. So how do we do that? Well, we have a number times the difference of two things. Think back to the previous video. We can use the distributive property to multiply this 3 into each of these two terms separately, and then we're going to take the difference of that product. So I have the 3 times the 2x, which is 6x. The 3 and the 2 obviously multiply out to 6. And then I have minus the 3 times the 4, which is 12. Okay, then we would check, are there any like terms that can be combined? This term contains an x. This term does not contain an x. Therefore, these aren't like terms. You know, this is all we can do. And then the operations on the like terms, well, we don't have any more like terms. We just have to leave this as it is. All right, moving on to the next one here. 6y plus 1/2 times the quantity 4 times y squared minus 10. All right, we see we have some grouping symbols here. So let's take care of those grouping symbols. I'm going to do the same thing as I did in this problem over here. This 1/2 is going to multiply into the 4y squared and the 10. So I still have that 6y. That still remains the same. Now plus 1/2 times the 4 is going to give me 2 minus the 1/2 times the 10, which gives me 5. Okay, grouping symbols are gone. Do we have any like terms that we can combine? This is just a number. This is a term with a y. This term contains a y too, but this guy has a y raised to the second power. This is a y raised to the first power. So none of these are like terms with any of the others, so we cannot combine these. We can't do any operations to combine these like terms. So this is fully simplified as it is. All right, next one, 2 times x times y squared plus 5 times x squared times y minus 17 times y squared times x. We don't see any grouping symbols here, so we have to see, are there any like terms here? We're seeing x's and y's in each of these terms, so let's see if there are any terms where the powers on the x's and y's match up. Here, x has an exponent of 1 and y has an exponent of 2. Here, x has an exponent of 2 and y has an exponent of 1. So these two terms are not like terms. Here, y has an exponent of 2 and x has an exponent of 1, well, that's what we had in this term here. Same variables and same exponents on those variables. So when you have terms that are like terms and they can be combined, what you do is you only change the coefficients on those terms. You don't change the variables and you don't change the powers. You just change the coefficients. So what I'm going to do here is I'm going to keep that 5 times x squared times y. And now I have the plus 2xy squared minus 17 y squared x. We said that these two terms were like terms. So what you're going to do is you're going to perform the indicated operation on the coefficients of those terms. So here I have 2 of these things, and I'm subtracting 17 of those things. So what is 2 minus 17? Well, that's negative 15. So that gives me 5 times x squared times y minus 15 times x times y squared. Or you could write 15 times y squared times x. Doesn't matter, means the same thing. And we said that these were all of the like terms that we had. We can't combine any more terms. So all the operations have been done, and this is now fully simplified. And I'm going to let you try the last problem there on your own. Go through the process of simplifying algebraic expressions. Remove the grouping symbols, combine like terms, and do any operations that you can with those like terms. So guys, this concludes our video on section 1.7, and this concludes chapter 1 on sort of just a general review of some basic math concepts. This video in particular on simplifying algebraic expressions. In the next video and the next chapter, we are going to begin to talk about linear equations. If you have any questions or comments, be sure to reach out to me, guys. Send me an email, stop into my office, give me a phone call, whatever you have to do. Until the next video, take it easy, guys.